Okay, so let's see how you would actually go about graphing inequalities. So again, it's just a visual picture of what's going on sort of algebraically. So how about graphing the following? 3x. Oh, actually, let's make it 2x. I think 3x is a little bit beyond my scope right now. So let's just do 2. So we have 2x minus 3y. And let's say that's greater than or equal to 1. Okay. Well, now, how would you graph this kind of inequality? Well, the first thing I would do would be to consider the sort of auxiliary object going on in the background, which would be what I would have if I had an equal sign there. So I'd first do a warm-up problem. And the warm-up problem I would consider would be 2x minus 3y equals 1. Now, what's the graph of that? Well, that's some sort of line. And if you want to see exactly what that is, I could write this maybe in slope-intercept form. So I'll solve for y. If I were to solve for y, I would bring this minus 3y to this side and bring the 1 over here. And I would see 2x minus 1 equals 3y. And if I divide both sides by 3, I'll write the y over here, though. Y equals, I would see 2/3 x minus 1/3. Just divided both sides by 3, and then just wrote them in reverse order. So then I can see exactly what's going on here. I see that y is going to be equal to 2/3 x minus 1/3. So the y-intercept is minus 1/3, and the slope is 2/3. What I'm going to just do here is record the original question, and then write down this auxiliary thing, y equals 2/3 x minus 1/3. This here actually represents sort of the boundary, and this is going to be one of the regions. Now, let's actually see what this would look like graphically. Well, we have this line, and we know the line is this. So its y-intercept is -3. So I've got a line, and its intercept is -3. -1/3, rather, I'm sorry. So this is, let's say, -1 is here, so -1/3 would be around here. And the slope is what? It's 2/3, so that's 3 over, 1, 2, 3, and 2 up, 1, 2. So it would look just like that. Sort of a thick line. But notice that the origin is above the line. I hope you can see that. Maybe I'll exaggerate just a little bit for clarity. I'm cheating here a little bit. But there you go. Okay, now, that's not what we were asked to find. What we were asked to find, of course, was this inequality thing. But I know that this is going to cut the world up into 2 pieces, and one of those pieces, either the upper piece here or the lower piece here, is going to actually represent all the solutions to this. How do I figure out which is the solution? Well, all I do is pick a point in either region and see if it satisfies the original inequality. So, for example, I could pick 0, 0. There's the origin. And ask, does 0, 0, x equals 0, y equals 0, satisfy this? Well, let's see. If we plug in 0, 0, I'd see 0 greater than or equal to 1. Is that a truism? No. 0 is not greater than or equal to 1. So, in fact, the upper region must be the wrong region. We must be looking at the lower region. And so all I then do is shade in the lower region. So I would do this like so. So, in fact, this inequality is, the graph of that is this line and all the things here in green. And in fact, notice that since this is a greater than or equal to, I actually include that boundary right there. I actually include that boundary. That's part of it, because that's where this equals. Neat. So there's a neat one to sort of take a look at. Let's try another one. Sort of get in the mood for this. Let's look at the following. Let's take a look at x plus y is less than 3. Well, what would I look at first? I'd first look at sort of a warm-up auxiliary thing where there's equals. If I put an equals there, I'd see x plus y equals 3. If I solved it for y, I would see y equals minus x plus 3. So that's sort of a good warm-up to look at. And what's the graph of the warm-up? Well, the graph of the warm-up has a y-intercept of 3, 1, 2, 3, and a slope of -1. So it looks just like this. That's actually a pretty easy one to do. There you have it. Slope is -1. 1 down, 1 over, 1 down, 1 over, and it goes through 3. So there's the line. But now I'm looking at the actual thing I'm looking at is x plus y less than 3. So I'm either going to be in this region up here or that region down there. Which one? Just pick a point. And in fact, you could pick any point. I usually pick the origin when I can. Of course, I couldn't if the line went right through it. But if the line doesn't go through it, I pick that because it's so easy. Plug in 0, 0, and see if it's a truism. If I plug in 0, 0 in here, I see 0 plus 0 is 0, and that is less than 3. So this is the region of excitement. Oh. Region of excitement, and so I could color it. And of course, you want to color the whole region there. Now, the question is, and of course I should cover it. It's really sort of tricky to cover the whole thing. It's covered even up there. I'll just put my hand there. See, it's covered right there. Now, do I want to include the line or not? Well, since there's strict inequality, in fact, I don't want to include the line. So I actually remove the line. So it's everything up through the line, but not including the line. So it actually sort of looks like this. So there's the region right there. I'm going to put my hands here so you don't see the fact that I ran out of stuff there. So the region is all the stuff that's sort of below that invisible line. There's the graph of that. Okay? So again, it's pretty easy. Just graph the equality part and then ask yourself what side or what part are you on. Let's try some that actually aren't lines, just to see that, in fact, there's no difference whether you're a line or not. Suppose we look at y less than x squared. What would I do first? Well, first I would graph the analogous thing with an equal sign. So I'd graph y equals x squared. That's a standard happy face parabola right here. Notice that I have strict inequality. So I'm not going to actually want to include that curve. So I'm going to draw that curve dotted. So I'm going to draw that curve dotted. So I'm going to put in a dotted standard parabola. Dotted standard parabola. Ooh, okay. Beautiful looking parabola, by the way. But it's dotted because I don't want to include it. Now I've got to figure out whether, now notice the two regions are a little bit weird. There's this region here, and there's this region up here. And the question is, which one should I shade in? Well, I pick a point. Well, you might say, gee, I'll pick the origin. I can't pick the origin today because this curve actually passes through it. I've got to pick a point that's in one of the regions. So why don't I pick this point right here? That's 0, 1. So I'll let x be 0 and y be 1. And I'll ask, does that satisfy that? If I put a 0 in for x and a 1 in for y, is that true? Is 1 less than 0? No, it's not. So this region must not be the region that I want. So in fact, I shade the outside region, and so I'd shade this. And here's how I do it, by the way. So I shade everything. Of course, it keeps going, but I shade everything out here, and this actually is unshaded. So there's the graph of y less than x squared. Let's try one last one. How about look at the following, y greater than or equal to x squared. Okay, well, same picture. But now notice that I have a possibility for equality. So when I actually graph it, I can use a solid graph now. Still passes through the origin. And now I pick a point. I'll pick the same point. I'll pick 0, 1. If I put in 0 and 1, is this a truism? Is 1 greater than or equal to 0? Well, now it is true. And so, in fact, now I shade in this upper part here, which you can sort of do like this. And so this is the graph of this inequality. Notice the solid line, because I am allowed to have equals. Here, there's a dotted line because I'm not allowed to have equals, and I shaded in the right region. And this curve, notice that each curve will cut the world up into two pieces, and I just shade the appropriate piece by picking a point, plugging in, see if it satisfies it. Up next, we'll take a look at more of these shady issues. I made a little pun on the shade. Okay, see you soon.